This is our second video on vectors. In the last video, we learned how you can define two-dimensional vector or three-dimensional vector or a vector say having elements 4 or 5. But suppose if you wish to create a vector which has large number of elements, then using the conventional approach which we have learned in the last video is not at all efficient. So in this video, we will see how you can create a vector which has large number of elements in it. So let's get started with our second video on vector. So over here, if we use this function, say x is equal to 1 colon 10, then it will create a vector which will have the first element as the value 1 and the last element will be having the value 10. So let us see what will be the output if you use such kind of statement. So the output would look like this. So it will create a row vector, and if you look at the difference between any two consecutive value, we see that it is equal to 1. So the step size is equal to 1. Now let us take another example. If I give the statement something like this, then it will create a vector which will have the starting value as 2 and the final value as 5, and the step size will again be 1. So this is how the output would look like. You can also give the negative values over here. So if I give minus 4 colon minus 1, then the starting value will be minus 4, the final value will be minus 1, and the step size will be 1 again. So a row vector will be created, and these would be the values for the row vector. So you can give any value, whether it is positive or negative, but the only thing which you have to remember over here, it is that the step size will be 1 over here. But now suppose if you wish to create a vector which has a different step size, so that can also be done using Scilab. So let us see how it can be done. Now if I give the command something like this, then 1 colon 2 colon 10. Now over here the first is the initial value, the starting value. This middle value will tell the step size, and 10 is the final value. So if we give a command something like this, then the output would be that this is how the row vector would look like: 1, 3, 5, 7, 9. So the starting value is 1, the step size is 2, and the final value will be either less than or equal to the value which we have given over here. So this thing we have to remember over here. The final value which we'll get in the vector will be always less than or equal to this number which you will give over here, depending upon what is the step size you have given. Now if we give something like this, then the initial will be 2, final value will be either less than or equal to 8, and the step size will be 3, and the output would be 2, 5 and 8. Here we see that this final value over here, the last element is matching with the final result which we had given over here. We can also give the fractional value as the step size. So if we give the statement like this, then it will create a row vector which will be having the step size as 0.5, and the final value will be less than or equal to the pi. So over here we see that we are getting 3 over here, because if we add 0.5 to it, 3.5, it will exceed the pi value. So that is why the final value will be 3 and it won't be 3.5. So this is how you can create a vector of any step size using this simple command. You can try this kind of a command also, and I think now you can see what the output would be if you execute. So if I use this command, we see that we are going to get the result like this, which is a vector. And now suppose if you wish to multiply each and every element of this vector by, say, any scalar value, then how can it be done? In Scilab, it is very simple. You don't have to make use of the root, but you have to simply make use of this kind of a statement. So if I define another variable x2, which I write down as 2 star x, then what will happen? Since x is a vector, x2 will also be a vector. So in this x2 vector, every element will be 2 times the element which we have in the vector x. So the output will be like this. So first element is multiplied with 2 gives us 2, the second with 2 gives us 4, and so on. So every element of x vector will be multiplied with this scalar value, and the resultant will be again a vector. So we don't have to make use of the for loop which you are familiar with in C++. Instead, we can simply use this kind of a statement, and that will serve the purpose. Now suppose if I have to multiply every element of this vector with 3, then we can use this kind of a statement, and this is how the output would look. So this is the output of this vector. Now suppose if I wish to square each and every element of this x vector. Then for that I have to make use of element by element multiplication operator. So x dot star x, if I make use of, then we will see that xs cube is another vector which will be created, and every element of this xs cube will be the square of the element in x. So the output would be simply this. So 1 square will give us 1, 2 square 4, 3 square 9, and so on. So every element is squared up by making use of this element by element multiplication operator. Now suppose if I ask you to cube each and every element of this x vector, then I think you can do it. And how it can be done? By making use of this operator. Again we have to make use of this dot cap 3. So it will compute the cube of each and every element of the vector x. So things are simple and no programming is needed. You have to simply make use of this operator dot star or dot cap for the cube or for the square. Now suppose we see that over here we are getting the result in the row vector form. But suppose if you wish to tabulate the results in the tabular form, then how it can be done in Scilab? Because most of the times we have to display the result in tabular form. So for that this can be done something like this. So x is a row vector, so if I take the transpose of it, it will give me the column vector. Similarly for this and similarly for this, and if I put it in a square bracket, then it becomes a vector. So if I make use of this and display it, then this is how the output would look like. And the more formatting can be done, which we'll learn in our later video. Now we will learn about the linspace inbuilt function. This linspace inbuilt function creates a row vector of n linearly equally spaced points between x1 and x2. And this is the syntax for the linspace function. So let us try to see and learn about it with the help of an example. Now if we use this statement in Scilab, then this linspace function will be called, and the first element tells the initial value, the second element tells the final value, and the third element tells how many points we wish to generate between this 1 and 2. So if we execute it, then 5 points will be generated between 1 and 2, and the output would look like this. So here we see that we don't have to give the step size like we did in the earlier case. Here we have to simply tell the number of points, and then automatically the step size is being taken care of. Now if you wish to generate say more number of points, 50 number of points between 3 and 10, this is how you can use the linspace function. And to create 100 points between 0 and pi, this is how you can call the linspace function. So you can execute these statements and see how the output would look like. I am not going to execute it, but you can do it on your own. Now over here in this last statement, if we don't give the third argument, then the default value is taken as 100, and 100 points will be generated between 1 and 2. So this is how linspace function can be used to generate as many number of points as you want between the initial value and the final value. So in this video we have learned two ways to generate a vector which has large number of elements. And these two ways are very commonly used in Scilab, and we will see how these will be used when we have to do the plotting and we have to do the numerical analysis. So we will see the applications of this in our later video.